And now I'll introduce our next speaker, Des.
Thank you, thank you, thank you. Good morning. How's everyone doing? How are we doing today? Awesome, awesome. Who's ready to talk about serverless security? Okay, nice, nice. First, I'll introduce myself. I'm Des. I work at Capital One as a software engineer. I also happen to be a certified ethical hacker. So I like to do things I'm not supposed to do. I like to have a little bit of fun, and that's what we're gonna do today. We're gonna get you also having a little bit of fun. I hope you have your devices, because I'm gonna get you involved in what we're doing here. You're also gonna get hands-on as well. We're going to take a look at a few things. The first thing I'll do is I'll introduce the topic. I'll talk about why we're here, what we're talking about, why we want to discuss this, why is this important. Then I'm gonna take us over to getting you to interact with this yourself, so you'll get to see what hacking a serverless environment is like. And then we're gonna talk about how to make sure this doesn't happen to you, how to avoid the pitfalls that we're gonna see today, and where you can go to learn more. We all set? All right, give me a clap. Give me one clap if you are familiar with serverless. You know what it is. Okay, give me two claps if you've used it before, you've deployed a serverless application yourself. Okay, give me a clap if your company is thinking about using serverless. What about if your company is already using serverless? Give me a clap. Okay, okay, so we got a good mix in the room. The problem facing many technologists like you and I, folks who are using serverless or thinking about using serverless, is the problem of complacency. That's where we're going to start today, is the problem of complacency. Anytime we have something innovative, there's usually a level of complacency that follows it. And I'll take you back to an example myself of where I for the first time, used Uber. So I used to live in Richmond. I had just moved to Richmond out of school. I went to Penn State. Any Penn Staters here? What? There we go. Okay, nice. So I went to Penn State, and I left Penn State, and I went to Richmond to start working for Capital One. And I wanted to go out for the first time and see what downtown was like, but I didn't want to drive. So I said, maybe there's a way to get downtown where I can just maybe take a taxi and then come back. I know it's gonna be expensive, but it'll be worth it. And I thought to myself, I don't know the number to call, so let me just look in the App Store. Maybe there's like a taxi cab app that I can use. So I opened up the App Store, and I see this Uber app. And I downloaded it, I put my payment information in there, and then I waited 15 minutes, and someone was at my house. And I remember thinking as I'm walking up to the door of the car, this doesn't look like a cab, and it's a little bit different. I open the door, I get in, and when I'm nervous, I start to talk a lot. I start to talk a whole lot. So I was in there talking to this person that was driving, and at the same time I'm wondering, is this safe? Where are we going? Am I really going to the destination? How am I gonna pay? Do I need to pay with cash too? What are we doing here? Does this person do this all the time? And I was just asking the person questions, and I'm sure I got like 2 stars for that ride. But now, today, fast forward to today, if you see me in an Uber, I'm probably asleep, or I'm probably complaining about the fact that it takes 15 minutes to get to me. I've become a little bit complacent myself, right? I've taken it for granted now. Now, I want to shift that thought to not just customers being complacent, but companies being complacent when it comes to something innovative that is no longer innovative anymore. So think about companies like Blockbuster or Kodak, right? Let's talk about, if you're a 90s kid like me, we can talk about MySpace and how that changed social media forever. And now, if you ask the people today about what MySpace is in the next generation, they'll have no idea what it is. So there are examples of companies who also get complacent after something innovative, but then they don't make any changes, and things just dry out. Let's take this mindset, this train of thought, and apply it to the topic of the day, which is serverless. We have this amazing innovation. Google Cloud has given us, AWS, Microsoft has given us serverless. Essentially, you as the customer, you get to focus on just delivering the code, and they will take care of the rest. There's no infrastructure for you to worry about. What that means is now you can actually write the code without hassle of worrying about the infrastructure, what servers are behind the scenes. Does that mean we don't have to worry about security? Yes or no? Yes. What's your name? Brendan. So Brendan says there's a shared security model. The cloud provider will take care of some of the security, and we can kind of focus on writing the code. I think it's great. You get charged on the computation. It just makes a lot of sense, right? It just makes so much sense. Why would I not want that? Why would I want to be caring about what's happening behind the scenes with the infrastructure? I do want to bring our attention to a concern that I think we're approaching really quickly. And I want to pump the brakes a bit just to make sure we're focusing on the right things as we're navigating to this new way of deploying applications. And that's the topic of the day. That's what we're going to be focusing on is serverless security. And we're going to look at that very closely ourselves on the devices that you have in your hands. I want to show you how many companies are actually running to serverless and give you an idea of the adoption, right? So here's a look at some of the levels of adoption for serverless within AWS, within Google Cloud, within Azure, right? Things are changing pretty quickly. Even folks who can't use Lambda, for example, in AWS, they're able to stop using traditional servers and they'll go to ECS. So this is the rate at which companies are now using AWS Fargate and no longer using ECS. So things are changing here. We're migrating to a much easier way to deal with deploying applications. We're getting to a point where we can actually do what we want to do, which is solve customers' problems. But it does change the way we need to be thinking about security. And there's some positive things, there's some negative things, and there's some things that stay the same. We're going to see all of that today with our devices on our hand. Let's talk about some of the things that are positive. So if you're using serverless, you don't have to worry about patching the servers because you're not responsible for them. The cloud provider is. It's much tougher to get into a scenario where you're being attacked in a denial of service attack. It's also much more difficult for attackers to do stateful attacks. So folks like myself who I'm an ethical hacker, certified ethical hacker, I don't get the opportunity to do long-term attacks like I used to. It's much more difficult to do that. Let's talk about the things that are going to stay the same. So you still do need to worry about permissions, you still need to worry about the vulnerabilities in your code, and you still need to worry about your data. This is the area where I think some of us are starting to overlook things because we've been told you don't need to worry about anything. You don't need to focus on what's happening behind the scenes. Just worry about the code. This is where we're going to draw some attention to today. And then let's talk about some of the things that have changed for the worse. These are the things, and we can probably argue back and forth about these, but these are the things that I think are changing a little bit. So let's talk about the changes in attack surface. So if you have a serverless application, most likely you're going to be in a scenario where you have multiple functions. So for example, if I had an application that I wanted to allow people to upload memes and show their friends funny memes, I would probably have 5 functions. I would have a function that checks whether you're giving me the right format. I would have a different function that uploads your image to a S3 bucket. I would have another function that pulls it down so everyone can see it. I have a function that'll check whether you're giving me a file that isn't something insecure. I would have so many functions, and that means I'm a little more spread out, right? That means my attack surface has increased. I have more things to worry about, and it's probably harder to keep up with things like logging and monitoring. Here are the top 10 risks for serverless. And the ones we're going to see for ourselves today is we're going to do some injection attacks for ourselves. We're going to see some insecure configuration. We're going to see some overprivileged function permissions. And we'll also see what happens when you don't store your secrets in the right way. We ready to do that? All right, I think I've talked enough. Let's jump into it. So we're going to hack a serverless app. It happens to be a Node application. In the backend, it uses a DynamoDB database. It's using Lambda. We're going to take a tour of it next. I'm going to show you what it looks like, but I want to make sure you have access to it first. So go ahead and scan this. This will take you to the app that we're hacking today. It'd be nice if this side uses Serverless 2 and then that side uses Serverless 1. We could spread out the love a little bit, but I think AWS should be able to handle our impact today. So let's see, once you get access to that, you should see something that looks like, I'm going to give it a moment because I think folks are still accessing. You should see something that looks like, it should say at the top, convert your docs. Is that what you're seeing? Okay. So that is our play box for today. That's where we're going to do our attacking. I'm going to take you behind the scenes to see what this app that's on your phone looks like. What you're looking at is the front end, and this is what the back end looks like. So there's two functions that run here. Very simple. You have your function that converts documents, and then you have your function that displays the front end that you see. So this app essentially is an app that converts documents to text. If you give it text, it'll convert the document. Very simple. And then the other thing I want to show you is some of the code behind the scenes, what the function looks like. So if you're editing this function, this is what you would see. Kind of hard to see on the screen, but you essentially have HTML code, and then the other function has a converting code. So this is the function that converts the document. It's just going to take the document. It uses a library called catdoc. It's going to convert the document to text. So look at how flashy we are. We got all of this going on. We're taking this document, we're converting it to text. This is like high-end stuff. This is pretty cool stuff we're doing here. Now I want to take you to using the app. So let's use it the way we're supposed to use it. You should see in yours, there's already a URL filled in there. There's already a document in there. You can actually convert the document. And you should see something that looks like this. So I'm actually converting a dad jokes document. I happen to be a new dad, y'all, so I'm sticking to the dad joke thing. I'm not leaving it. I'm gonna be telling jokes all day. How many new dads in the house? Anybody that's a new dad, like within the last year? How many dads in general? Okay, cool, awesome. So I wish y'all would have told me how amazing it is to like wake up and see someone smiling when they just woke up. It's amazing, awesome stuff. So now you can actually submit this, and you should see the text, which is a bunch of dad jokes. Is that what y'all are seeing on your screen? Awesome, okay. Now, this is how you use the app the right way from the user perspective. This is a serverless application. It's not doing anything fancy, it's converting text. You've seen the back end, you've seen the user perspective. Now we want to do some actual attacking here. We want to think about how we would attack this application. So that's where I'm going to need your help. I'm going to get you involved. And it's going to be tough. We're going to face a little bit of challenge here, but I'm here to help you out. What would we do? Let's say we wanted to actually attack this environment. So we'll go back to this screen here. How would we attack this environment? What would we potentially be able to do if we wanted to manipulate this page here? Any thoughts? Upload a compromised doc file. I like that. So maybe you could get it to run a script that it's not supposed to run. What else? Sorry? Oh, single quote, double quote to see what happens. So what's your name? Jakob. So you want to change the input and put something that really isn't supposed to be there. Let's say I said, this application is actually accepting any input that you want. What kind of input would you start with? What would you put in there? If you wanted to be tricky and use something that's not supposed to be there, what would you put there? A script. I like how y'all are thinking. But let's be simple to start with. Let's gather some information first. So how do you know what this app is doing? How do you trigger an error, right? How do you gather some information? Generally, as an attacker, you want to start by just gathering information. You want to see what environment am I using, and what app is this? What application is this? What what kind of language is it using. So I want you to, on your page, try changing the input completely, change the input. And after you've done that, I want you to enter in your browser /prod/convert and then hit enter. So at the top in your browser, in the URL, you're going to change the URL to /prod, capital P-R-O-D, and then /convert. So basically, we're going directly to the conversion page, and you should see something that looks like this. So if you keep the URL at the top, where you get past the .com, after the .com, do /prod/convert. And I'll give you a moment to do that. What you're essentially doing is you're going directly to where this submit button takes you to. So we're navigating to a place where the submit button was supposed to take us to, and we're going to trigger an error. You should get an error that looks like this. Anybody there yet? Missing authentication token, okay, nice. So we're triggering some errors, which is what we want. When you start this kind of thing as an attacker, you want to gather information. So if you have this on your screen right now, you've triggered the kind of error that will get us going in terms of figuring out what this application is like behind the scenes. So what does this error on the screen tell us? What kind of information can we gather just by looking at this error on the screen? Do we know what type of language it's using based on this? JavaScript. How do we know that? Not because I told you, but because, yes, .js. What if we wanted to see what this code looks like? So we wanted to go to that path. How would we do that? What's that? Open up Inspector. Okay. Open up Inspector. We might. I see you have your laptop. You could do that. I'm curious if we could get to the page that has this particular code. So I want to directly access the code for this page. How would we do that? We could put it in the browser. What about here in the input where it says enter a URL? Is there a way we could get to that path by entering some information here? What would we do? I've given you some information. I'm telling you that we can actually enter commands here. So what kind of command would we enter here if we wanted to see that particular file? Dot, okay. So we could go to the directory. What would we enter here to see that? Okay, we're getting there. What about if you entered this? What is this doing? Looks interesting, huh? So we're giving it a URL because that's what it's expecting. We're giving it any URL, and then we're saying, hey, I'm going to actually write a cat call, a cat command, and then I'm going to navigate directly to that file that we were talking about, which is this file, /var/task/index.js. So now you should be able to, on your screen, see what? What will you see? Yes, you'll see the content of the index.js. Why is this necessary? Why would I want to see the code behind this page? What am I going to do with that? Why would I want to see the code? Yes, and your name is? Oh, Natalie. Okay, so Natalie, you're right. We can see the actual code that's behind the scenes. So we can see what this developer wrote, and that'll give us information to use to get to the next step. So I've cleaned this up for us, and I've put it on a nice, pretty page so we can see the code itself. If you need to see this one more time, I'll put it back on the screen. Enter this, and you should see the code for this application. Okay, so now we have our code. We have some information about how this application works. We see that it's using some environment variables. We see on line 12, it says process.env.table_name. So we've got some information. We know it's using a database behind the scene. What if we wanted to grab that environment variable? So we want to know what the table name is because we want to access the data. How would we do that? If we want to get to the table name, we would do some injection. Okay. Okay, I like where we're going. So we could do an env and grep for the table name. We would absolutely just do that. We would just type env. So I want you to do that to see what happens on the screen, and I want you to tell me the table name that you see. You're going to enter HTTPS://. The reason why we're entering that is because this application has been written in a way where it's expecting some input for a URL. And then I want you to write the command that we would write in a terminal if we wanted to see all of the environment variables. And what do you see? You see AWS secret keys. All right. So now we're getting somewhere. Now we are like, we're cooking with some fire here now. So you should see something that looks like this. You should see AWS secret keys. You should see table name in there. You should see access keys. We can do some stuff with this, right? So we started with just triggering an error, and then we navigated towards getting environment variables, and then we use those environment variables to actually get some information. Now we have some secret information that shouldn't be accessible to us, but we're essentially just taking advantage of not correctly sanitizing or encoding or escaping the input that's being given in the application. So what do we want to do next? What are we thinking about next? Keep exploiting, right? Let's keep going. Like, why would we stop here? There's more to do. So we have some information. I want to take you to what's going on behind the scenes. So you have your bucket name here, and you're probably thinking, okay, so if this is my application, like where would I like, how do I make sure this doesn't happen to me? You essentially, in the backend, have your environment variables stored in plain text in the configuration within AWS here. And that's why we're able to see all that stuff here, because you've stored it in plain text. So basically your secret, you've put it in plain text, and you'd be surprised how many companies are doing this, how many developers or engineers are doing this. It's just the easy way to do it. It's the fast way to get it done. It saves time, it saves energy, and that also saves time for the attacker, right? The attacker is also able to get to this information very easily if they can bypass your input in the front end. Now we're gonna do something a little more tricky here. So if you scan this one, I saved you some time because I didn't think you could type all of that, but if you scan this one, what it's gonna do is it's gonna take you to an attack that gets data from the database. Let's dissect this one a little bit. So if you see on the right side of your screen, you have your URL, and then you're doing a lot of stuff. You're doing you're pulling in Node, and you're pulling in your AWS SDK, and then you're doing a console.log. You're logging the entire table. You're logging the table scan using AWS's DynamoDB SDK. So you're pulling in all of the data from the table and directly placing it on the screen. And it should look like this once you get to that. So what is stored here? Remember, if you go back to the code, we were storing IP address, we were storing document URL, we were storing ID. All of that stuff is in the database. So anyone that has come to this application, you can see their IP address, you can see what they entered, you can see where the ID is for their application. And this is why you can see that. So essentially, we have written our IAM role in a way that just doesn't make any sense. We've given this particular application all of the access that it does not need. So we've given it get item, delete item, put item, scan, query. Which one of these do you actually need of this list that you see in the actions? Which one should you actually have for this application? Yeah, you probably just need put item and get item. You don't need to have this particular function be able to delete items or to scan the table. It's as simple as writing this in a way where you only give it the necessary permissions that it needs. So this is what being over permissive looks like. This is what not following least privilege permissions looks like. And it's very easy to do in AWS. It's very easy to do with serverless because it just saves time. You just write it this way, you take the default, and you move on. There's also a way to get to the S3 bucket, and if you were to actually look at the data that's being shown on your screen, you could navigate to the bucket easily on your own. But we're not going to do that. I'm going to leave that for you to do on your own. I want to ask us about how we learn from this. So what are we supposed to be doing? I've showed you all of the things that we're doing wrong. What are we supposed to be doing? We should absolutely be using least privilege because you saw there when you have all of the functions and the actions available, it opens up the hole, it opens up the door for the attacker to walk in. We should be using a secrets manager for our secrets. So remember I showed you on the screen, we had our environment variables back on this page here. We should be using a secrets manager for this kind of thing. Our information, very sensitive things like table name, should be stored in a secrets manager of some sort. We should be watching for what's happening in our environment. So we should be keeping a close eye on the things that are happening. And it's a lot harder to do this in serverless because there's so many functions. It's going to be tougher to monitor all of them, to keep track of all of the logs, to see why is this particular function running at a time where no one should be using the application. Something fishy is happening here. It's a lot harder to do that. We obviously need to be minding our code and the code that our code is using. So any libraries we pull in, we have to be mindful of the libraries that they're using, their dependencies, and the vulnerabilities within them. We need to be sanitizing our input. We saw just right there on the screen what happens when the input is not sanitized. And this is a big one. This is one that we don't do very well or we don't do often at different companies. We don't always threat model. We don't look at our applications and say, okay, how could this be manipulated? And you just saw within 5 minutes how easy it is to manipulate an application that isn't doing the right things. So here are some resources for you. I think what I want you to do after you leave here today is practice this for yourself. And I don't want this to be a thing where I'm saying serverless is bad. That's not what I'm saying. I'm absolutely saying let's go to serverless, but let's do it the right way. Let's say today I decided to give each and every one of you a Tesla Model 3 for walking into this session and listening to me today. Some of you would get excited and drive. Some of you would say, oh, I don't really like Tesla. I don't like electric cars. Keep that away from me. And then some of you will go beyond that and actually drive the car, become an enthusiast, maybe buy some of the services, the features. Let's say you buy like, what do you call it? The autonomous driving, right? The full self-driving. Let's say you buy that. There is a percentage of people in this world who are excited about that and are using that, but they're also using it in a way that it's not supposed to be used by falling asleep in the car, right? Think about that for a second. So we've gotten to a point where some of us feel comfortable allowing a car to drive on its own and falling asleep in the car. That's the example that I'm trying to show you here is that like, yes, we should chase towards innovation. Yes, we should be innovative, but we have to keep our seatbelt on and keep our foot on the brakes just in case, right? We have to stay awake because there will be mistakes made. And I fear that we're getting towards that in the way that we're using serverless. Thank you. Any questions at all? Anything that I can answer to help folks be ready to make their jump as well? Yes, Natalie.
Hi. What is it in the code that allows the execution of the bash commands?
Good question. So let's go back. Let's see if we can actually share that on the screen. So within this application, wait, let's go back a couple more. So within this application here on the, that's pretty small. Within this application, I didn't build this application. This is available for anyone to use. It's called Serverless Go. Within this application, we're using a library that is vulnerable to arbitrary code execution, I should say. And essentially, if you're using this and you haven't updated to the latest version, you're opening yourself up to accept input that runs arbitrary code the same way you would run code on a terminal. So the input that's on the screen that you see on your phone, it accepts whatever you give it. It's going to run a command if you give it a command. So we could essentially write a command to shut down, and it would shut down. We could write a command to copy files from the server over to another place, and it would do it, simply because it's accepting whatever you give it and not really challenging you or not really encoding or escaping the input. Pretty scary stuff, but very simple to solve as well. What other questions do we have? Anything else that I can clarify? Yeah.
We'll have exactly the same problems if we had a server, right? It's
Yes.
input annotation and stuff, environment variables. What do you think the biggest difference is from server to serverless?
So your name is Peter. Okay, yes. Peter called out something that's really, really important here. We would have the same problems if we were using an environment that is just a server on its own somewhere, right? We would have these problems. We would need to worry about the code itself. We would need to worry about the secrets. I think the biggest difference here is now the problem spreads to not just your application, but other applications that are using the same environment, right? So like, let's say you happen to be running a serverless environment and you have allowed yourself to be vulnerable to this attack where someone can see all of the information for your AWS account, right? And your company happens to be using an AWS account where everyone's sharing that environment. Now you haven't just given up your information, your data for your application. You've actually opened up the possibility of someone using the token and the secret access key to access the entire account, right? To see what's going on in the S3 bucket in different places and getting other data that has nothing to do with this application. So I think that's where the impact is a little bit different, is we're not just focused on this scope where it's just your server. It can expand beyond that, right? The other thing that I think is different is it might be a bit more difficult to manage all of the functions that are set up in your account because of the scale of it, right? So you're not going to have 5 services for 5 functions in your account. You might have thousands in your account. And the moment you have a function that also has access to another function, you're opening up a vulnerability where now the attacker just has a field to play with, right? They're going beyond just attacking your application. They're attacking other functions that have nothing to do with your application. You have a question here?
Hi. In your personal experience, how have you found like each cloud provider to be maybe slightly more proactive about maybe warning folks when things like this happen? Like I know for Lambda, at least in my experience, you're kind of left at your own whims, like you showed here. Like AWS isn't reaching out to you to be like, did you know you can do SQL injection in your thing? But in your experience, do you find like the experience is different between various cloud providers or between various services within these providers to help you?
From what I've seen, it's not different enough. There hasn't been enough from any of the cloud providers. And I agree. It's not on them to really do this. I haven't seen much of a difference between GCP or AWS. I haven't used Azure a ton, but I haven't seen much of a difference in terms of helping me avoid some of these mistakes. In fact, AWS would kind of almost, I don't want to say entice me to do this, but it's kind of on me if I did this, if I set this up in this way. And I don't think AWS is doing enough there where they could say, hey, you might have this issue. Because it's really not their problem, per se. It's your app, you set it up this way, you opened it up. They can't go and check your application. They already have to deal with patching the server itself and making sure it's set up with the latest and greatest. They can't go checking your application as well. So it's on you to do that. I place the onus on us as users to use the application right. Just like I wouldn't blame Tesla for people sleeping in their cars, I wouldn't blame AWS for people misusing serverless. I love that question. Any other questions? Yeah.
Cheers. Maybe just one thing to add to the answer to your question. GCP does tell you when your permissions are too much. So that's one thing that they do proactively do. And like with default service accounts in GCP and with default policies, and like Lambda has an AWS Lambda execute. Oh yeah, great, I'll use that. That gives you a read write on all S3 buckets in the account. Yay.
Does AWS warn you about that? Does it say?
No.
They don't? Okay.
No, it doesn't do that.
Interesting.
And also, is there something in AWS, so in Google, not for functions, but for containers, if you store your container image in the artifact registry, there will be a proactive scan that goes and maybe checks for libraries that are vulnerable, if you enable it, of course. So at least you have like a built-in scanner. Is there something like that in AWS?
For Lambda?
Maybe not for Lambda, but maybe for Fargate.
For Fargate. For Fargate. Or for Lambda? Okay. Yeah, I haven't seen it for Lambda, but I do see the inspector for other services, for other things. Yeah.
I don't think ECR is doing anything proactively, though. Their container repository, I think you can just put whatever you want in there.
Okay. Your name is? Jason. Jason says you can also turn on code scanner for ECR. Yeah. What other questions? Love these questions so far. Anything else that I can clarify or add to? All right, y'all have been awesome. This environment is gonna be up for a while. Feel free to use it and attack it. It is my personal environment, so I'm gonna be spending some money if you go too far, but have fun with it. And thanks all. Have a good one.